I am now
Yeah.
recording a little meet with Shuen and myself. This is Randy Schuster to talk about doing simulations such as the particle collider in in physics or chemistry or some other type of thing. So the goal here is to provide a workspace where students can practice with sets of variables and get a visual understanding of whether it worked or it didn't work, the result was good or it wasn't good, or just to learn something about the interactions. And this is the most basic one that we can give, which is a particle collider, right?
Hmm.
So, as an example, if I start at -20, -20, -20, and my other one starts at 90, 90, 90, and I want to give them velocities, starting velocities where I know that they'll hit. So I'm very simplistic. So I'm going to give them ones that are like, this is like about as simple as you can get, right?
Yeah. I
And then,
play a yeah.
right? And then I'll give
Mm-hmm.
them particle sizes, which are just right now a visual size. And I'll tell
Mm-hmm.
them I want to bounce off of each other. And then when I start, they go and they collided. And I know where.
Mm.
So this gives you lots of ways to set up um, problems for them to run, right? You can
Mm-hmm.
say, you can give them this information and say, where will they collide? Well,
Mm.
I've got a thing, and well, let's just see. And yes, indeed, they did collide where you said, or no, they didn't collide where you said. Or maybe you say, I'm going to give you this and this and this, and I'm going to give you a collision point.
Mm-hmm.
Give me these velocities. Or I'll give you these and give me these velocities. Or I'm going to give you this, and you give me this and this so that they'll collide, period. Who cares where they collide,
Mm-hmm. Mm-hmm. Mm-hmm.
right? So it's just a kind of a way to let people practice over and over and over again and visualize and see that they've got the result. Now,
Mm.
one of the things that I did is I started saying, well, what happens if I make that -30?
Okay.
Is it gonna work? Well, it did. Look, it actually is working
Mm.
at the correct angle.
Mm-hmm.
And how if I go -40 and give that one a try? So, and it's like, oh, they collided. Cool. I wonder if I can keep going. I'll bet you the answer is
Mm.
no. Right? It's like, huh? What's gonna
Mm.
happen? Oh, they missed each other. Now, there's a few other things that we can give. And right now, so by the way, this was done about a year and a half ago, and
Yeah, I remember that. Yeah.
we
Mm-hmm.
barely got it working. So quit doesn't work. I'll do a stop. Let me do stop so that it just oops so that the thing just stops. Oh no. So Tristan has to fix up a bunch of this stuff, but just think of the things that we could do. We could actually pass back nearest point of passage so that you could have them figure that out. We could put gravity in here. Right now there's no gravity.
Mm-hmm.
So if we wanted to, we could just turn gravity on and give these things a mass depending on their particle size or density or whatever.
Mm.
The tool is incredible. We can even give elasticity to the particles.
Mm.
So now, and we can put gravity, we can put attractive or repulsive forces
Mm-hmm.
between the particles. They're all in the Unity engine. So of course, we just started with the most simple thing we could think of, if you can just imagine what it would be like if you could have a student progress through these, we don't have to have them particles. We could make one a jet fighter and one a missile. We could make one the moon and one the earth, and you shoot a rocket off of the earth. We could, this rotating around it. We could make the earth spinning with a rocket on it and trying to hit the moon and just hit the moon or hit a spot on the moon. The ability for us to model based on this simple set of functions is incredible, because we can do XYZ, we can do velocities, we can do torsions. They're all part of the simple physics engine in this program.
Mm.
Does that give you some ideas?
Yeah. So you actually you answer one of my question is the mass, and you said the Unity has the engine. We can add the mass.
Mm-hmm.
The mass is to the particles. That's actually probably will be
Yeah,
the
because
first thing actually. Yeah.
you know, this is great for doing the law of motion, right? But then when they hit each other, these are essentially massless objects right now, and you quickly get beyond that, right? Like,
Yeah.
so yes, we can do mass, we can do momentum transfer. It'll actually, if you say it, it'll change its speed based on the momentum change. That's in the engine already. But what I like about it is that the student gets a fast feedback, and it's a fast visual feedback. We can make one of these explode into pieces, or maybe one of them is an atom, and when this electron hits it, quarks come off of it. I don't know, right? Our ability to model is there now. Here's, to me, the key thing. It's done in a web browser.
That's really good.
Right? So your student just needs the web browser. Now, we've got these already where we're reading input values from a spreadsheet or a CSV file. And it can either be an external file, or you copy and paste this into a box. So you saw me type. What a pain, right? We could have this either on a JSON or an Excel spreadsheet, or just a CSV, and just paste it into a box. And if they formatted it right, it'll just work. It could also be that you give us, 20 examples that you're interested in, and we say, do example 1, example 2, example 3, example 4, and they can be various examples, and we can preload. So those are very easy for us to do now. We have a very good input-output system that talks to other files that are on the Power Server. We can talk through Google Drive, basically.
Okay, all right.
So, or we can talk through a CSV data input box.
So you mean we can upload the CSV file?
Yep.
For those, yeah, okay.
Yeah.
That's great. That's great.
Yeah.
It's good, especially it's the student-led project, and it looks really good.
Yeah.
Yeah.
So and then the other thing, we can actually put sound files to this too. So it could be that you have a description of the problem, and they have to set it up. So you could say, okay, I've got 2 of these things, and they are, 50 meters apart. And by the way, we can use any set of units that you want. And they're 50 meters apart, and you're going to do this, this, this. And you can deliver that through a sound file, or through an image file, or as a link to a video that you've made. Or you could even say, do problem 42 from your workbook, right? So
Mm-hmm.
we've got also the ability to integrate sound files.
Mm. Yeah, that's this is really good. My thinking is this. I would love to share this with the department, and then gather the feedback. Says okay, then
Hmm.
what can we add on here? For example, the for me, like the masses, and
Right.
also the final velocities after collision, and you also mentioned about the elasticity, just those are basic elastic collision or non-elastic
Hmm.
collision, and we can
Yep.
decide that. That would be really helpful. In the past year during the COVID, I used quite a lot of online lab simulation, but those
Right.
are already made, so we don't have much say on those. But
Right.
since this is our student design those, yeah, I love to get the feedback from the other colleagues,
Okay.
and then I'll send it to your team. Yeah, and
Yeah.
then they can go from
Right.
there.
So as an example here, you would have particles collided at particle one,
Uh-huh.
final velocity, particle two, final velocity.
Correct.
Something like, yeah,
Yeah.
very, very
Yeah.
easy to do. It's all in there. It's
Correct.
just us figuring out what you want it to say.
What features? Uh-huh.
Right. And then whether you want us to download this. So that's the other
Uh-huh.
thing. We can have a download button so that people can keep a record of it. We can do an
Uh-huh.
image capture button so that they
Uh-huh.
get an image of it. This is in a horrible spot. I mean, this is like the,
You
the
just
user
block it.
interface is like, what made him think about putting that right on top of the collision? Why wasn't this over here, right? So there's tons of stuff. Like for me,
Mm,
this, what they did is they put the camera on the blue one, focused on the yellow one. And this
mhm,
one, the camera is on the yellow one, focused on the blue one. Well, that's not
mhm,
very descriptive. But if I had an X, Y, and Z camera,
mhm,
then you could start visualizing where those things are really going,
mm,
right?
mhm,
As well as seeing it here. And maybe you even want the ability to rotate this space live
mm,
so that you're seeing it. We can
mhm,
put camera controls in here.
mhm,
Um, this is like, okay, I stood up and we want to get, I can run fast and do high hurdles, right?
mm,
But we'll
mm,
get there. And pretty quickly, if you can give me, even just for you, a list of 3 or 4 simulations that you would like
mm,
to start at the beginning of the fall, I'll get
mm.
those done in the summer
Ooh, whoa, okay.
because our programmer who Tristan, you know Tristan, right?
I met, yeah.
Okay, so he works for us as temp, classified temp, so he only
Mm,
gets 960 hours a year, but he's also a certified vendor. So when we stop his intent in the summer, we get to pay him as a vendor until the
okay.
fall. And I've
Ah,
got boatloads of money to help faculty. It's like there's this huge pot of dough for me to make things that are useful for the faculty.
mhm,
And so that's what I want to do. And I can actually cut him a PO easier than I
mhm.
can do working with HR and time cards and all that other kind of stuff. So
You are great, gosh.
I can,
You are good at this, yeah.
so I'm going to do the bungee drop for Bill.
Mhm,
And because I know what he wants, if you give
mhm,
me like, okay, the first one is what you see here cleaned up. Then I want you to add mass. Then I want you to add, what are the velocities when it's leave, or and you tell me what you want the output to be. Then I
okay.
want you to add gravity. Then I
Mm,
want you to, so go through like what you would think a progression of a student that knows nothing other than
Mm-hmm.
the math,
Mm-hmm.
going through the progression of what they're supposed to learn from nothing, because I'd also like to present this to high schools.
Mm-hmm.
This would be something that, okay, high school physics teacher, here's your
They can
first
use.
one,
Okay.
here's your second one, here's your third one, here's your fourth one. And maybe it won't be until the third or the fourth one until, you know, it's ready for the class that you teach,
Mm.
right? But if you could go through that step by step from the most simple 5 or 6, scaffold it till it's to the point that you want,
Mm-hmm.
and then maybe 2 or 3 after that. Literally, I could get 6 or 7 of these done over the summer, and then let me
Over
know what
some.
your
Okay.
what do you want your background to look like too.
This
Um,
looks.
well,
Oh
these
yeah.
these
This
are
looks
not good
fun. Yeah.
because you can't tell where you are or where the
Mm.
movement is going.
Mm-hmm.
I'm thinking like a checkerboard with squares here and diamonds here, and
Oh, like a grid.
yeah,
So you
some
know. Okay.
yeah, some sort of a grid so that people can see that it's moving past and which
Mm-hmm.
one we're kind of looking at. But
Mm-hmm.
if you've got an idea of what makes sense, and we originally started this as a cloud chamber, right?
Mm-hmm.
And so if you'd like this to be a big cylinder that we're looking at from the outside and all we see is the gas trail, you let me know.
That might be a different lab, but
Right.
I think this 3D collision simulation is good. I'll send you.
Yeah.
Not this
And
week, probably.
okay, that
Yeah,
sounds so great. That is so
early
cool.
summer. I'll
Yep.
send you yeah, and
Cool.
I'll send you a list of probably 5 features if you guys.
Awesome.
Yep.
Yep. And then feel free, please do share this with everybody in the area or the
Okay.
department.
Okay.
We do have and if anybody goes, oh, what I really want is I want to see the planets circling around the sun,
Mm-hmm.
and I want to see how a rocket goes from one to the. I don't care what they're asking for, right?
So Randy, are you looking for a different project by using similar engines? Is
Yes.
that, for example,
Hmm.
for astronomy? Of course, we can. This actually can apply to for like astronomy, doing those, the the the
Oh
motion of the
yeah.
celestial bodies.
Yep.
So the Apollo might have a different ideas about this.
Right.
So
Right.
okay,
Yes.
okay,
So yeah, we are so wide open, and in the fall, right now I have 2 programmers, Tristan and Shadiha. In the
uh,
fall, I'll have Shadiha's sister added in and 3 others. I'm going to have 5 programmers. And so at the
okay.
start, for the first 8 weeks, the new programmers will be sort of useless because they'll be learning, right? They
Mm-hmm.
got to learn the engine and how this works. But starting at week 8, I'm expecting us to really be able to pump stuff out and thinking of prepping for the spring. I'm
Mm,
teaching something in the spring and I want to and just have fun, It's like
mm.
if students can have some fun while they're doing this, that would really be cool.
Yeah, I get a very interesting feedback from students that they're doing the online lab,
Yeah.
and the positive part is the student says, okay, I now I can manage how to do the lab myself. So they kind of play around it, and
Right.
that is something actually in person lab it probably is not. They don't have that privilege to do that because
Right.
the safety issue. We have to tell them, okay, you can only do this, that.
Right.
but
Right.
but yeah, but online actually simulation actually do have that
Right.
features, have the student, give the students more freedom to test something different. So
Right.
yeah, okay, definitely
Cool.
yeah, I'll give you the list, and at the meanwhile I'll share this with department like engineering department, the physics department, and astronomy department to see what what I think.
Yep. Oh, hold on a sec.
Okay.
My shark needs to refresh himself. There
Oh,
there
you're
we
afraid
go.
you're shark. You
Yeah,
need.
there we go. Now I'm happy. So So there, and so just in case, it's getting into lunchtime. So I think I'll turn into this guy for a second. There we go. Now I'm ready to.
Now I'm hungry.
Yeah. So anyway, okay. Well, Shwen, thank you so much. We really, really, really want to work for the department. We want to do things that make life easier and better for the faculty and in a way that is not onerous.
Mm-hmm.
And also let us know what outputs you want to make life easier and better so that this is as most useful to you as possible.
Sure. Yeah. And like I mentioned, early summer by the probably
Yep.
after final week, I should be able to work on this.
Cool.
And before final week, I'll share the link
Cool.
with
Oh,
and also the recorded video with the faculties.
cool. And we should be able to give like 5 to 10 hour ESAs for a bunch of faculty to work on this. We're not expecting faculty to give up their time for free to develop curriculum tools. That's not really in the in the sphere of what they're supposed to do. And so I know they'll spend more time than that, but we want to at least recognize that their efforts in developing something like this are critical.
Okay.
And so that they can, if they have some ideas, they can talk with me and we can set up some small ESAs, including for you, to be able to work with us and our interns to make sure that it's like useful and real.
Okay, that's good though. That's great. And just a quick question. So, what about flex hour? Can we count this as a flex hour?
Oh, absolutely.
Okay, that's
So
great.
yeah, because I mean, what are we doing? We're learning about new cool stuff
That's
to
right.
to get flex hours and all that.
Uh huh.
So yeah, you can,
Okay.
and I'll send you the recording so you have proof that we did it, and it's on my calendar, so
Oh
you
no, no,
can.
not for me actually,
Oh,
but in
oh,
general for the faculty, they put their time and to work
oh,
with students on
oh,
this.
oh,
Yeah.
yeah,
Okay.
that would absolutely be flex hours, but why would you do flex hours when you can get an ESA and get paid?
Oh,
I
okay.
mean,
That's true.
they've got so many stuff that they do their flex hours in. They probably so far go over
That's
the,
true.
the
That's true.
limits. So
That's
so
true.
I know your administrators are going shush 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 right now. Be quiet. Um, but yes, we could easily set these up as
Okay.
approved flex hours, the amount
Okay.
of work that gets done.
Mm-hmm.
But I'm a believer that even at the low compensation rate of an ESA,
Uh-huh.
it's proper and appropriate to signify that we really appreciate our faculty and their efforts by compensating them.
Mm-hmm. That's
So,
great. Okay. I'll
cool,
I'll yeah, I'll let the faculty know as well
cool.
for the ESA.
Yep. All right.
Okay.
Okay. Well, I'm going to stop the recording now.